With the recent climatic situations we have seen in Chennai, with the rains and subsequent flooding, our next session comes almost as a need of the hour discussion. This session will be on technologies for urban flood mitigation. I would request Professor Ashok Jhunjhunwala, President of IITM Research Park and Incubation Cell, and Professor Balaji Narasimhan, IIT Madras, to please come on to the dais and share their insights on this critical area.
This is the final session of the conference. Of course, there is a conclusion after this. And it's a very important session. This was not part of the conference when we originally envisaged the conference on December 4th and 5th. But since December 4th and 5th was cancelled and it became January 4th and 5th, we said if we don't talk about this session, what we are going to talk in this session, then the whole conference is left incomplete. We all know about what's happening with climate change. The climate change is already impacting us. Two different things. This is a picture of my car getting flooded, which I had to abandon on December 4th. 50 centimeters of rain in 48 hours. The whole city was paralyzed. All of us know that quite well. And then, when we thought that finally things have settled down, it was a matter of 2 weeks or less than that, and the whole of southern Tamil Nadu was paralyzed. If someone thinks that it is not happened due to climate change, this frequent thing that's happening, then we are fooling ourselves. While we talk about, in this conference, we talked about technology and enhancing efficiency for non-fossil based technology to reduce GHG emission. I think equally important is for the next 50, 100 years, till we are able to go to net zero and reverse the damage that we have already done to the earth and its surroundings, we have to build resilience. And the first thing that came into our mind is these cities. Can we build resilience in these cities? And we have a person here, I don't know how many of you are familiar with, Professor Balaji. He has been working on this and has a very, very good understanding of what can be done, should be done. We thought that we'll begin with him, and then we'll focus on technologies required to build resilience. And I think with that, I'm requesting you, climate change is here, build resilience, and start.
Sure. So can I have the mic?
Keep pressing this.
Oh, okay. Thank you. Very good evening to all of you, and I'll try to make it as short as possible because this being the last session of the day. And flooding is something that is, all of us are, touched by it one way or the other. And, this is something where every one of us have an idea and suggestion on how to make the things better, right? And all of them are equally valid as well, right? So when we look at urban flooding, these are the various different reasons that we can talk about. One is the lack of drainage infrastructure, which is true in large parts of the city that is getting developed. Backup due to elevated downstream water level. For example, if the main river, the main stem of the river has lot of water, then the draining stream, the stormwater drain is not going to be able to effectively discharge. Flooding in low-lying areas. This is an example which you can see in Velachery and Taramani. Depending upon if you are from this region, you know what are the regions that I'm talking about. Backup due to elevated downstream water levels. This is something, for example, if Adayar gets a lot of water is released from Chembrambakam and if water level goes up. The another case is during the recent cyclone event, there was a very high tide level. So the water level actually swelled up in the river and there was, the stormwater drain was not functioning, right? The inundation caused by high water levels, so this is something, the 2 and 4 are somewhat related. And of course, blockage is something that all of us are very familiar with. Solid waste, sewage, whatever that you can think of is getting dumped into the stormwater drain, and then that will also lead to flooding. So there is something called as fluvial flooding and pluvial flooding. I don't want to get into the techniques of it. So can we use technology to build resilience, right? So so I will focus on some of the state-of-the-art technology that are there right now, and where the government of India as well as government of Tamil Nadu are working on to make use of the state-of-the-art technologies, where there are still lacuna is there, where the technology can probably play a role. So that's a sort of open sort of question and discussion that I would want to have. So when we talk about flood mitigation, there are two things that we need to think about. One thing is a fail-safe, and another is a safe fail. Fail-safe is typically a kind of a structural measure where you try to build an embankment or a flood wall and things like that. If that kind of a system, if it actually fails, then the result will be catastrophic, right? So that's what is called as fail-safe, and we need to build them in such a way and with so much of lesser risk that it should not fail. But then it's going to have significant economic implication. There is going to be a lot of capital cost and operational maintenance cost and things like that going to be there. There is something called a safe fail. These are mostly non-technological measure, non-structural measure, technological interventions, sensors, forecasting systems, management systems, how the city is basically planned, floodplain zonation. So many of these things are typically involved. And mostly we might need to focus on safe fail system, and this is where technology can also play a much more larger role. Move on to the next one, please. So just to give some examples on what I mean by fail-safe and then a safe fail. So here, we know at what level some of these things will fail. We can adequately forecast, we can take precautionary measures, and we can give sufficient lead time so that we are actually prepared mentally for the event. Fail-safe is something that it is catastrophic, that we cannot even mentally be prepared for a thing. So this is where a lot of technological intervention can basically come into play. So I'll try to focus on the safe fail measures, some of the things that the government of Tamil Nadu as well as the government of India are focusing on. So for the past, since 2015 flood, there was understanding the importance of that. The principal scientific advisor to Government of India started a project to look and see how a pilot flood forecasting system for Chennai can be developed. So IIT Madras was involved in that. So a pilot flood forecasting system was developed. The government of Tamil Nadu took it up further and then significantly enhanced that with the funding from World Bank. Now, for the past 3 years, that there is a real-time flood forecasting system that is under development, and then IIT Madras is actually supervising and mentoring the development process. It's done by a private company, but then IIT Madras is completely supervising the whole development process. So, you have a lot of topographical data, a lot of digital elevation model that is collected for the topographical data, a lot of hydrologic, hydraulic models, a lot of mathematical equations and other things are all there. And there are infrastructure in terms of, the control rooms and then hardwares and softwares that are necessary for that is also getting deployed and developed. So this is just to give an idea of how such a system will look like. So you will have a lot of sensors that will be deployed on the field. The sensors are going to be sending in real time how much amount of rainfall is happening, how much amount of, what is the water level at various different streams, at reservoirs and things like that. And they are going to be coming to a control room. And from the control room, there is going to be a model that is going to be running at the forecast mode. And then there are going to be information that are going to be disseminated to several offices, field offices, where critical decisions need to be taken. Some of the critical decisions could be when the reservoir need to be opened, when the reservoir need to be closed, what are all the places where people need to be moved, and things like that, right? So this is so the Chennai floods dss.in. So a dashboard is already there. A lot of the work that are being done since we are piloting the system. We have been piloting the system in 2022 and 2023. But this is with whatever the minimal sensors that are installed. So, and there are a lot of sensors that are going to be installed, hopefully before the beginning of this monsoon season. Next one. So now, when rainfall exceeds the drainage capacity, right? So typically, this is one such condition when rainfall exceeds the drainage capacity. Can we simulate the things? Do we have the technology? Yes, there are technologies that are there, and this is being already simulated in the real-time flood forecasting system and spatial decision support system. So we have the state-of-the-art methods and techniques and models and things like that that are there. Baseline mapping, yes, there are techniques that are available. There are these are being mapped, and this is there as part of real-time flood forecasting system. When I talk about Chennai, this you can generalize it for other cities in India as well. So this is already possible. So what rainfall should be prepared for, right? So this is also again, can you click once more? So there are manuals and codes by CWC, National Disaster Mitigation Authority, National Disaster Management Authority, and then you have the Central Water Commissions. So they have a specific set of codes and manuals that are there. The designs of your stormwater drainage systems as well as your flood control and mitigation measures are all dictated by these. For example, if there is a high economic area, for example, airports and things like that, we would prepare for 1 in 100 year. But then if there is a city infrastructure, for street level infrastructure, stormwater drain, it will be designed for about 1 in 2 year to 1 in 5 year. Mega cities like Chennai, it is designed for 1 in 5 year return period flood. So 1 in 5 year return period, when we say, there is a 20% chance of that flood occurring, so that's 1 by 5. There is a 20% chance of that flood occurring every year. So it is not like this flood will occur only once in 5 years. That's what Professor Jhunjhunwala is saying, that because of the climate change, so 1 in 5 year is occurring like every other year, right? So mapping of floodplain, flood-prone zones, technologies for elevation mapping, ditches, potholes, and things like that.
Can we do this? I mean, can we now develop technology? Can we have
Sir,
startups?
microphone, yeah.
Sorry.
Yeah, yeah.
Oh, I didn't actually. Yeah, can we have startups? We're saying all low-lying areas in every part of the city. Today, for example, using GPS, we are now even measuring the amount of traffic at every point. Can we find out every low-lying area and slope to determine water flow and where water is likely to fill? Even in the smallest water fill, can we actually do this? Ditches, potholes. And I think it is possible. Develop digital elevation map. Today we are already developing with 1 meter resolution. Can we do it at 5 centimeter resolution? What kind of technology is required? LiDAR mapping for improved accuracy, airborne and terrestrial radars, reducing cost of differential GPS with real-time kinematic. Simulate waterlogging like traffic maps today. And how to frequently update the elevation. Can we even have pilot cars with things fitted and driving around? And can we kind of do this? Now, something like this is technologically feasible. And this is where lots of different startups can come and start developing technology. Remember, some time back, we couldn't even think of the kind of maps that we have today while driving. But something like that is possible and required if we have to really overcome the kind of problems that we are talking about. Then, communication system.
Yes. So, this is something I think maybe, after my blurb, maybe Professor Jhunjhunwala might be able to add a lot more. So this is one of the critical thing for all disasters. Communication, the network failure is basically one of the the most critical aspect. The 2015 flood, we experienced it. Again, in Tirunelveli and Thoothukudi during the 2023 flood that happened, there was a complete network failure, and that was experienced. So even when we develop these systems, the flood forecasting system, real-time decision support systems and things like that, they heavily depend upon real-time data from the sensor. If there is a total failure in those things, there are redundancies that are there in terms of VSAT and LoRa and things like that, but then are there sufficient redundancies that are possible? Are there other kind of communication system that we can get into?
I can elaborate upon this. We had, in fact, a seminar about a month back on this issue. Of course, wireless communication, 4G, 5G has given us an immense amount of communication capability. But we know, like in 2015, all the towers went blank for 3 or 4 days. So that alone will not help us. And in fact, there is a Hyderabad-based company which is working with us, which is now starting to launch low Earth orbit satellites. So in such a manner that on my existing 5G phones, I can communicate with them. With no change, just some software upgrade. On the existing 5G phones, can I talk to low Earth satellites? This is not a dream. This is already happening on pilot basis. Already, a couple of satellites have been launched. Over the next 4, 5, 10 years, we'll see plenty of that. And that can be used, of course, in sparse area where there is no nearby towers, but also in these emergency times. Of course, it won't give you as much capacity as the normal mobile phone. So we'll have to manage it. So figure out, but we should give you all communications required for managing floods and also all emergency communication. We have to work out a protocols. Because suddenly from satellite, if you allow, it will be possible to do it from all phones. But what do you allow, what do you not allow is something that we need to figure out. And it is something that we should work on. This is something doable. In fact, I'm going on next Monday to have another meeting with Jaisima, who is actually developing. This is a company in Hyderabad which is developing this technology.
Then the another important, when we talk about rainfall, we assume that it is the variable that is very easily measured. But then rainfall is the single most uncertain variable in hydrological modeling. And hydrological modeling is key in urban flood modeling as well as flood forecasting. So, when you, even when you travel, you would have noticed, you would have traveled for half a kilometer, there would not have been any rain, and then another half a kilometer, you will see that there will be an intense thunder shower that will be happening. So, one of the ways where we try to capture the spatial variability of rainfall is through Doppler weather radar network, right? So, even though you may have lot of rain gauges, it is possible that your rainfall can miss many of these rain gauges, or you may not capture the highest intensity of the rainfall, the spatial distribution, the variability, the temporal variability you may not be able to capture. Of course, the Earth observation satellite, these satellites that we are talking about, these are polar orbiting Earth satellites. So that means it is not constantly there at one location. It is constantly revolving. So that there is a latency. There is a latency in terms of data acquisition, and there is a latency in terms of data transmission as well. So now, for this forecasting system to work, can we move on to the next slide, sir? So, is it possible? One thing is, can we enhance the weather radar network? And that's going to. There are C-band and X-band radar networks that are being explored and that are being looked at. But then, the mobile tower, the communication tower that we are talking about, also works in similar sort of wavelength ranges. And then, of course, you might have encountered microwave interference or radio signal interference when there is a heavy shower and things like that. So can we look at this microwave interference, because we have cell phone towers that are ubiquitous everywhere, right? So is it possible for us to look at this? work with the cell phone, the tower providers, and see if it can be used for making a quick assessment in terms of quantitative precipitation forecast. There are few research studies that have been attempted in the countries, in the Western countries, but then nothing concrete has come out of it. Is it something that we can actually
Again,
look at?
excellent problem for startups. I think this is crackable problem. These are something that one can use. But as I pointed out, one very, very important, can we use sensors to map data of stormwater drains? One of the biggest problem is, yes, there are drains, but flow capacity without any blockage versus clogged scenario. Many of them are clogged. You see the kind of clogging that is there. And if it is clogged, even having the drains is not enough. Can we use light-based velocity meter be developed, acoustic Doppler velocity meter be developed to figure out all the blockages? Real-time mapping of all blockages, the nalas, gutters, channels, ditches, storm water drains, open drains, covered drains, ducts, water conduits, using data from sensors and inverse modeling approaches, and pass it on to Balaji to sort of put it into his simulation and say, okay, now with all that, what's actually happening? And can we then send it to the monitoring station and something like that? And finally, the citizen participation, extremely important. In spite of everything, we'll miss out things. But can we develop some simple mechanism by using simple cell phone? Can data be sent up? And as data, more and more data starts coming up, can we develop the image processing and the GPS location and figure out and correct our whole simulation? Can something like this be possible? Certainly possible. Technologies exist, and we really need to put together these things.
Yeah, so this is something, on the same thing which we have tried to develop on a modest scale. This is an in-house developed portal through the Center for Innovation. It's called chennaiwaterlogging.org. So essentially, it's a crowdsourced data that we try to get. But still, there is a lot of awareness and participation is still lacking from the common citizens. But if it is possible for us, this can also provide a lot of valuable information which can help us to correct our model, fine-tune our models, and then issue advisories appropriately.
So I think basically what we really need is an internet of flux. Just like we have today an internet of traffic, can we create an internet of flux? And this is what should be possible in the next few years, and it will help us in the mitigation. Pretty much, that's our presentation.